Most people memorize the OSI model, but they don't actually understand it. They can list all 7 layers for the Network Plus exam. But if you ask what actually happens when you open a website, things get fuzzy. So in this video, I'm going to break down the OSI model in a way that actually makes sense. No fluff, no overcomplicated definitions. By the end, you'll understand what each layer does, how they work together, and why the OSI model still matters in real-world networking. So what actually is the OSI model? At a high level, the OSI model is just a way of organizing how data moves across a network. It breaks network communication into 7 layers, starting from the physical cables at the bottom, all the way up to the applications you use every day, like a web browser or email client. Think of it like a delivery system. When you order something online, there are multiple steps involved: packaging, labeling, shipping, routing, and final delivery. The OSI model separates networking into similar structured steps so engineers can understand, design, and troubleshoot networks more effectively. It's not something devices literally run step by step. It's a framework, a blueprint for understanding communication. Layer 1 is the physical layer. This is the foundation of the entire OSI model. It deals with the actual physical transmission of data. At this layer, information is converted into electrical signals, light pulses, or radio waves. Cables, fiber optics, network interface cards, and switches all operate at the physical level. The physical layer does not understand IP addresses. It does not understand ports. It simply transmits raw bits, ones and zeros, across a medium. If a cable is unplugged, damaged, or improperly connected, communication fails at layer 1. Think of this layer as the wiring and plumbing of a building. Without it, nothing else in the network can function. Now we move up to layer 2, the data link layer. This is where things start getting structured. At layer 2, data is organized into frames. Each frame contains a source and destination MAC address, media access control addresses, which uniquely identify network interface cards on a local network. This is also where switches operate. A switch reads the destination MAC address in a frame and forwards it to the correct port. On the Network Plus exam, you need to associate layer 2 with frames, MAC addressing, switches, and error detection using mechanisms like CRC, cyclic redundancy check. Unlike layer 1, which only moves raw bits, layer 2 adds organization and basic reliability within a local network segment. If devices are on the same LAN, communication typically stays at layer 2. Now we move up to layer 3, the network layer. This is where logical addressing happens. At this layer, data is packaged into packets, and devices are identified using IP addresses, not MAC addresses. While layer 2 handles communication within a local network, layer 3 is responsible for moving data between different networks. This is where routers operate. A router reads the destination IP address in a packet and determines the best path to forward it toward its destination. On the Network Plus exam, you should associate layer 3 with IP addressing, routers, subnetting, routing protocols like OSPF and RIP, and packet forwarding decisions. If you're sending data across the internet from your home network to a server across the world, layer 3 is doing the heavy lifting. Without layer 3, communication would never leave your local network. Now we move to layer 4, the transport layer. This is where end-to-end communication control happens. At this layer, data is segmented, numbered, and managed to ensure reliable delivery between devices. The 2 most important protocols at layer 4 are TCP and UDP. TCP, Transmission Control Protocol, is connection-oriented. It establishes a session, ensures packets arrive in order, and retransmits missing data if necessary. UDP, User Datagram Protocol, is connectionless. It sends data without guaranteeing delivery, which makes it faster but less reliable. On the Network Plus exam, associate layer 4 with port numbers, TCP versus UDP, segmentation, flow control, and reliability mechanisms like acknowledgements. If layer 3 decides where data goes, layer 4 ensures it gets there correctly. Now we move to layer 5, the session layer. This layer is responsible for establishing, managing, and terminating communication sessions between applications. If 2 devices are communicating over a network, layer 5 keeps track of that conversation. It handles session checkpoints and recovery. If a connection drops, this layer can help resume communication instead of restarting everything from scratch. On the Network Plus exam, associate Layer 5 with session control, authentication handshakes, and session management between applications. It's not as visible as the lower layers, but it plays an important role in structured communication. Layer 6 is the presentation layer. This layer is responsible for how data is presented between systems. It handles data translation, encryption, compression, and formatting. Imagine two computers that store information differently. Maybe one uses a different character encoding or file format. The presentation layer ensures that the data is converted into a format both systems can understand. It also manages encryption and decryption. When you connect securely to a website using HTTPS, encryption happens here in the OSI model structure. This layer protects sensitive information by scrambling data before transmission and decoding it at the destination. Compression can also occur here. Reducing file size improves transmission efficiency and speeds up communication. Think of the presentation layer as the translator and security specialist of the network. It doesn't decide where data goes. It ensures the data is readable, secure, and optimized before it moves forward. Layer 7 is the application layer. This is the layer closest to the user. It's where network services are actually accessed. When you open a web browser, send an email, transfer a file, or use a cloud application, you are interacting with the application layer. This layer provides the interface between user software and the network. It does not move data itself. It defines the protocols that applications use to communicate, for example, HTTP for web traffic, SMTP for email, FTP for file transfers, DNS for domain name resolution. The application layer makes networking usable. Without it, the lower layers would move data, but there would be no meaningful services built on top of them. Think of it as the front desk of a hotel. The lower layers handle the infrastructure, the wiring, the elevators, the plumbing. The application layer is where the guest actually checks in and requests service. This is where networking becomes practical and visible to end users. Now that we've gone through all 7 layers, notice the progression. The lower layers focus on physical transmission and routing. The middle layers focus on reliable delivery and session management. The upper layers focus on preparing and presenting data for applications. The OSI model isn't something you memorize just for the exam. It's a troubleshooting framework. When something fails, you isolate the layer. Is it physical? Is it IP addressing? Is it port related? Is it encryption? Or is it application level? That structured thinking is what Network Plus is really testing, not memorization, but understanding.